Hello, how are you guys? I hope you are all doing fine. Okay, so today we're gonna be looking at gas stoichiometry. All right. So in the previous videos, I showed you guys how we can find the number of moles in a chemical equation. Okay, so today we're just gonna continue from there. We're gonna continue to do the how you find the volumes or pressure of gas produced in a chemical equation. Okay, so we got this question here, which is showing the combustion of methane in the presence of oxygen to produce carbon dioxide plus water. Okay, so first things first, we're gonna look today on the ideal gas equation. Okay, so let me write here. Okay, ideal gas equation. Okay, so this is the ideal gas equation. Let me just write it down here. It's PV is equal to nRT, where P is equal to the pressure, V is equal to the volume, N is equal to the number of moles, R is the ideal gas constant. Okay, and T is temperature in kelvins. Okay, just it's temperature. Okay, so the units we normally use on these ones, like on pressure, we're gonna be using atmospheres, and volume, the units are liters. Moles are just moles, and the ideal gas constant is a constant. Okay, let's talk about the temperature here. It must be in kelvins. Okay, so whenever they give you the temperature, you have to convert, or normally, most of the times, they give you the conditions. So normally the conditions they normally use, we got what you call the STP, which is standard temperature and pressure. So usually this one is at 0 degrees Celsius, which is equates to 273.15 kelvins, and also 1 atmosphere of pressure. Okay, so if they give you that the conditions you must use STP, which is standard temperature and pressure, you're gonna use the temperature of 273.15 kelvins and also 1 atmosphere. Also they can give you what we call RTP. So normally RTP is 25 degrees Celsius. If you convert this, it will be 298.15 kelvins. Normally the pressure is the same. Okay, so if they don't give you the one to use, you can just highlight which one you are going to use. Normally you must use the STP, which is the standard temperature and pressure. Okay, so we're gonna try to put we're gonna try to find the moles first here. Then we're gonna use this ideal gas equation here, which is PV is equal to nRT. Okay, so we're gonna find the moles first here. They say when methane CH4 combusts in oxygen, it produces carbon dioxide and water. Okay, so this is the balanced equation. If you start with 16 grams, how many liters of carbon dioxide will be produced at standard temperature and pressure? Okay, so we're gonna write this one first. We're just gonna rewrite it. so that you can compare the ratio of the moles so that you can see it clearly. So it's what? It's let me just, it's CH4 plus 2O2 to give us carbon dioxide plus 2H2O. Okay, so here we're gonna do so this one is 1, compare this to 2, 1, 2. So we are just comparing the ratios of the number of moles, which is 1 here, 2 here, 1 here, and 2 here. So we are comparing methane. So this is the methane gas we are comparing. We're comparing methane gas with carbon dioxide. So as you can see, the number of moles, yes, methane as to carbon dioxide, it's 1 as to 1. Okay, so let's just write it here, 1 as to 1, right? So if we find the number of moles like this, then we're gonna try to find now how much moles is 16 grams of methane. Okay, so we're gonna continue this one. Okay, so let me just rub on this one here so that we can continue on this page. Okay, let's just okay, let me just, so now we have seen that the moles, it's 1 is to 1. Let me just rub this. Okay. All right, now we're gonna continue. Now we see that it's 1 is to 1, which is what, CH4 is to CO2. That's 1 is to 1. Okay, so now we're gonna try to find how much is 1 mole of methane. Okay, so carbon is 12 grams plus hydrogen, it's 1, so it's 1 times 4, right? So we're gonna get 16 grams. So they also gave us 16 grams here, so we're just gonna do 1 more is equal to 16 grams. So they already gave us 16 grams, so it's just what, 1 more. Okay, if it was different, we're just gonna put 16 like over if this one was different here, then you can put it down, then you can find the number of moles, but now it's 16 over 16, which is equal to 1. All right, so it's 1 more of what, 1 more of methane. Okay, so now we know our N is equal to 1 mole, right? Now we're gonna try to punch it in our formula, which PV is equal to nRT, where we got our, okay, we're gonna not try to do subject formula here, which is nRT over P, right? Which is equal to N is equal to 1 times our ideal gas constant. Our ideal gas constant when you are using atmospheres, when you are using pressure, when the standard unit of pressure is atmospheres, is equal to 0.082. Okay, so our R is equal to what? 0. So it's a constant. When they give you pressure in atmospheres, this one is a constant, which is 0.082. Okay, so let's just come here, 0.082, right? So we say we are using STP, right? We are using STP. Yeah, it's highlighted, we must use STP. So the temperature here is what, 273.15 all over. We said we're using the temperature of what, of 1 atmosphere, the pressure. We're using 1 atmosphere, which is the pressure at STP. So now we're gonna get We're gonna just calculate this one. Then you're gonna see how much we are getting here. Let's just do a calculation. No, let's just come here, do the calculation. And let me just add something here. Let me just add something here. Okay, calculator. Okay. So just gonna calculate here and see how much we are getting. So it's what? It's 1 times 0.082 times 273.15. So this will give us 22.39, which is approximately 22.4. All right. So to give us what? 22.39. It will give us 22.39. This one is cubic decimeters or just liters. Okay, so approximately, so that's 22.4 liters or cubic decimeters. All right.
Okay, let's go.